Laws of motion. Let's go through the formulae needed to solve the sums. So the first formula we need is momentum. Momentum is equal to mass into velocity. If they ask you in the question, find initial momentum, then the formula will be mass into initial velocity. And if they ask you find final momentum, then the formula will be mass into final velocity. Next is change in momentum, that is final momentum minus initial momentum depends. Whichever is bigger, take that first, big minus small. So final minus initial. Sometimes if initial is bigger, if the body is slowing down, that time initial minus final. Okay, so change in momentum. You can also take m common, so it will be m into v minus u. The SI unit for momentum is kilogram meter per second, or sometimes you can see Newton second also. Similarly, for change in momentum also, the unit is kilogram meter per second or Newton second. Next formula is of rate of change of momentum, which is equal to delta p upon delta t. Delta p means change in momentum and delta t means small change in time. And as per Newton's second law, this is also equal to rate of change of momentum is equal to force applied. And we know that force is also equal to mass into acceleration, hence F is equal to ma. So combining these two formulas, we can write delta p upon delta t is equal to F, which is equal to ma. So whatever the question demands, use that formula. So SI unit of rate of change of momentum or force is Newton and CGS unit is dyne. Let's solve the first question. A body of mass 5 kg is moving with velocity 2 meters per second. Calculate the linear momentum. First write the data. Mass is 5 kg, velocity is 2 meters per second, hence momentum is equal to mass into velocity. Substitute the values. So the answer is 10 kilogram meters per second. Question number 2. The linear momentum of the ball of mass 50 grams is 0.5 kilogram meters per second. Find its velocity. So now momentum is given. You have to find the velocity. Let's write the data. Mass is 50 grams. Convert this into SI unit. That is 0.05 kg. Momentum is given to you 0.5 kilogram meters per second. Let's write the formula. Therefore, V will be equal to momentum upon mass. That is 0.5 upon 0.05, which is 10 meters per second. Question number 3. A force of 15 Newton acts on a body of mass 2 kg. Now this time we have to calculate the acceleration. So let's write the data. Force is 15 newtons, mass is 2 kg, hence acceleration will be equal to F upon m. Substitute the values, and that is 7.5 meters per second square. Similarly, force is 10 newton, mass is 5 kg, hence acceleration will be equal to F upon m, that is 2 meters per second square. Question number 5. Calculate the magnitude of force which, when applied on a body of a mass 0.5 kg, produces an acceleration of 5 meters per second square. Data. Mass is 0.5 kg and acceleration is 5. Very simple, straightforward question. Force is equal to ma. Mass is 0.5 and acceleration is 5. So the answer is 2.5 newtons. Question number 6. A force of 10 Newton, acts on a body of mass 2 kg, and the time given to you is for 3 seconds initially at rest. Initially at rest means u is equal to 0. First part, calculate the velocity acquired by the body. Using this data, I can find acceleration, which is equal to 10 by 2, that is 5 meters per second square. Now using first equation of motion, v is equal to u plus at, u is 0, acceleration is 5, time is 3 seconds, hence velocity is 15 meters per second. For the second part, change in momentum, you can find by using Newton's second law. As per that law, change in momentum upon time is equal to force. So therefore, change in momentum is equal to force into time. Force is given to you as 10 and time as 3 seconds. Hence, change in momentum is 30 Newton seconds. Question number 7. A force acts for 10 seconds on a stationary body. Stationary body means u is equal to 0. Now the most important part of this sum is force acts for only 10 seconds. Remember that. The body moves through a distance of 100 meters in next 5 seconds. So a body moves 100 meters in 5 seconds. This is the most important part of this sum. So distance traveled is 100 meters in 5 seconds. So what is the velocity? The velocity is nothing but distance upon time. Hence the velocity acquired by the body will be 20 meters per second. Second part is acceleration. Acceleration is equal to v minus u by t. Substituting the values. Now again the most important part. How much time to be taken away? 5 seconds or 10 seconds? 10 seconds, because force was acting for 10 seconds. Hence the answer is 20 by 10. So therefore acceleration is 2 meters per second square. And the last part is force. Force is equal to ma. Substitute. Hence the magnitude of force is 200 newtons. Question number 8. Graph is given to you, velocity time graph. Mass is given 100 grams and they have asked you force. Force is nothing but equals mass into acceleration. Step number 1, convert mass 100 grams to kilograms. Hence I can write mass is equal to 0.1 kg. Now what about acceleration? We can calculate acceleration by finding the slope from this graph. So acceleration is slope. You can use the formula y2 minus y1 upon x2 minus x1, or you can also use height upon base. So therefore acceleration is 4 meters per second square. Substituting the values, therefore the force is 0.4 newtons. Question number 9 is similar to your 7th sum, the one which we did just some time before. In that question, velocity was not given. Here the velocity is given. Okay. So mass is 2 kg, time 0.1 second. Initially at rest, velocity is given to you 2 meters per second. So let's calculate first acceleration. Acceleration is v minus u by t. So 2 minus 0 upon 0.1, that is 20 meters per second square. Now force. Force is equal to mass into acceleration. Substituting the values, hence force is 40 newtons. Question 10. Mass 100 grams. A ball is moving with the speed of 30 meters per second. So converting mass into SI unit, initial velocity is 30 meters per second, is brought to rest. That is v is equal to 0 and the time taken is 0.03 second. Calculate the average force needed. This sum can be done by two methods. So I'll do both of them. In first method you will get the answer in minus, so don't worry about that. Minus means it is retarding force. Okay. First step, I am finding change in momentum where I am taking mv minus mu. So it will be 0.10 minus 30. So the change in momentum is negative. According to Newton's second law, force is nothing but equal to rate of change of momentum. Substitute the values. Answer is minus 100 newtons. And this minus sign stands for what? That this is the retarding force. Or you can do by the other method, that is change in momentum is nothing but, I told you, big minus small. U minus V also I can do. So the mass is same 0.1, but now it will be 30 minus 0. So therefore 0.1 into 30, that is 3 Newton per second. Hence force, which is equal to rate of change of momentum, that is 3 upon 0.03, and answer is 100 newtons. Both answers are correct. If you get minus, just write it over there that this is retarding force. It is not that mathematics wala minus sign. This is for showing that the initial speed is more than the final speed. Final speed is 0. Okay. Question number 11. Mass is given to you 480 kg. Initial speed is 54 kilometers per hour. Convert it into SI unit. That is multiplying with 5 by 18. That's 15 meters per second. It is brought to rest. It is stopped. So therefore V is equal to 0, and this happens in 10 seconds. Calculate the force. Let's find acceleration first. That is minus 1.5 meters per second square. Remember what is minus? That is retardation, because the body is stopping, the car is stopping, that's why. Calculate the force. F is equal to ma. Substitute the values. You can substitute with minus sign or without minus sign. So the answer is minus 720 newtons. So what is the minus meaning? It is retarding force. Hence the answer is 720 newtons. Question number 12. A bullet of mass 50 grams converted into SI units, that is 0.05 kg. Initially it is moving with a velocity of 100 meters per second. So that is U is 100 meters per second. And then it comes to rest. After penetrating a distance of 2 centimeters, again this is not in SI unit, converted into SI unit, that is 0.02 meters. Now step by step. First part, calculate the initial momentum. Initial momentum will be mass into initial velocity, that is 5 kilogram meters per second. Final momentum will be equal to mass into final velocity. Mass is 0.05, final velocity is 0, hence the answer is 0. Retardation cost can be, you can find it by using third equation of motion. So I'm using it over here. V square is equal to U square plus 2AS. Substituting the values, you get minus 0.04 is equal to 10,000. That is 2,50,000 meters per second square. Retardation. Minus A is called as retardation. So if you want to write the answer, so the third answer will be retardation will be 250,000 meters per second square. And the last part is force. Force is equal to mass into acceleration. Substitute the values, and that's 12,500 newtons. Question number 13. Force causes an acceleration of 10 meters per second square, and the mass of the body is 0.5 kg. Let's calculate force. Force is mass into acceleration. Substitute the values. So force is 5 newtons. Now the second part of the question says, what acceleration will be produced? Acceleration is F upon m by the same force. Force is 5 newtons, but now the body of mass 5 kg. So mass is 5 kg, hence now the acceleration produced will be 1 meter per second square. Question number 14. A car is moving with uniform velocity of 30 meters per second. So U is 30 meters per second. It is stopped in 2 seconds. That means V is equal to 0, and the force applied is 1500 newtons. Calculate the change in momentum. According to Newton's second law, change in momentum is nothing but equal to force into time. Force is nothing but 1500 and time is 2 seconds. So therefore the answer is 3000 Newton second. For retardation, you can use V is equal to U plus AT. Therefore, minus 2A is 30, hence minus A is 15, which is nothing but retardation. Therefore, retardation is 15 meters per second square. Now, the mass of the car, last part. We know that F is equal to ma, therefore M will be equal to F upon A. Substitute the values. Hence, the mass of the car is 100 kg.